Hello everyone. In this lesson, we will explore dynamic memory allocation and how they work in C++. Dynamic memory allocation in embedded systems allows programs to allocate memory at runtime using operators new and delete in C++. This helps in managing variable size data structures or objects dynamically as needed. In C, or those who come from the C background, they must be aware about malloc and calloc for memory allocation, as malloc is one chunk of memory is allocated, and in calloc there is a contiguous block of memory allocated, and the keyword free is used to remove clear the allocated memory during runtime. So what happens is that all the situations differently that is provided in C, malloc calloc, it is done in C++ using new keyword. So let's start by copying our existing code. Let me copy it and paste it. I will rename it to dynamic memory. Close the project. I will begin with deleting temporary files. Then in the source, in main.cpp, I will remove the previous code. In here, I will show how we can allocate the memory. So like if I take example, I'm creating one sensor variable, then printf, enter number of sensors, and let's return a new line and carriage return. Then we will scan f and %d comma sensors. So this is our normal variable allocation. And now let me show you how we do it using new keywords. So I am taking this value sensor data. So each sensor will have its own data, and we will calculate the average of that data and get the value. So to allocate, we use new float, and how many sensors we are taking, so that only we will pass as the uh, for the new memory allocation. Like if we pass the sensor value as 10, so it will create an array of 10 memory allocations over here. So let's printf and check enter sensor values. Let us create new line and carriage return. Then for int I equal to 0, I less than sensors, I plus plus. I'm keeping it very simple to make you guys understand how it works in C++. Scan f %d comma sensor data, and I will pass in the array I. Now for sum, I will take float sum equal to 0. For int I equal to 0, I less than sensors, I plus plus. In here, I will calculate the sum of the values or sensor data. So I will write a shorthand sensor data I. Now the average would be float average, that will be equal to sum divided by sensors. So like if we have selected 5 sensors and we have 200 as the sum, then it would be 40 as the average data. Average sensor value ampersand D carriage return, comma, average. And now what we will do is we will delete the memory allocation over here. So delete sensor data. So when we are taking an array of data, then we use this bracket to delete it. And when we are using a single variable, then we don't need to use the array like bracket for the arrays. Okay. Now let us build this project and let us run and see in our. Okay, some warning is there. Sensors used uninitialized and okay, it should be ampersand f and sensor data. It should also be ampersand f for floating values. It shouldn't come now. Warning should go away, but still we are getting this warning format ampersand d in pointer, but I want to have type int. Okay, okay, it should be ampersand over here, sorry, and also over here. So these are the small things you need to remember every time. Okay, the warnings have gone. Now let us flash and check. Let me run the code. I'll select the default settings. Let me open my Terraterm. Can be serial count and let me reset my board. So enter number of sensors. So I want value 5 that is not visible. I think it's not visible because it's not echoing. So to echo that, we need to come over to the terminal settings and local echo should be turned on. And now if we press, now we can see the value. Okay, let me clear the screen, clear the buffer, and let me just press it. Okay, okay. Now enter number of sensors. Like I am entering 5. So sensor value. Now we need to enter sensor values. Like I am taking 12, then 34, then 23, then 54, then 34. So the average value is 31.400. That is coming correct. I will show you why we are not getting the new line. So it should be turned to LF. Okay. So CR and LF. So there is some conversion problems between Terra term and the UART. So that's why I'm not able to show you. Maybe it would fix the values over here. Clear buffer. Let me press number of sensor value 5. Okay, enter sensor values 12, 25, 35, 78, 45. So the average value is like 39. Okay, if you calculate it 8 to 10 and 5, 3, 15, that is 25. Uh, and then you can see that it is allocated. And at the end, after this, the sensor data memory is removed. So what is happening after the delete? Why we provide delete? It is the same reason because after dynamic memory allocation, if we don't delete, it won't it won't clean up and there will be a memory leak. If there is a memory leak and the pointer goes out of scope, then what will happen? The memory leak will eat up free memory while the program is running, and you will get very less memory available for all the programs that are running through your application. We already know that in embedded systems, we lack the memory. Okay. So that's why we use delete keyword to clear up the memory. So this is how we do it in C++, using the delete keyword for clearing up the memory that is dynamically allocated, and using the new keyword to allocate the memory.